Dear viewers, this video is presented to you by the Rajiv Institute of Technology, Hassan, Department of VLSI Design and Technology. I am Mrs. Ambika K, working as Assistant Professor. The first experiment of the lab, Digital Logic Circuits, Simplification and Realization of Boolean Expressions using Logic Gates and Universal Gates. The first of its kind is simplification using basic gates, and we have taken here the expression y is equal to a plus bc b plus c bar a. So this expression has to be simplified because whenever the simplification process is going on, it is going to reduce the number of logic gates. So that's why before the given expression has to be simplified, and then for that particular logic diagram should be built. And for the simplification procedure, we have to make use of appropriate Boolean theorems and laws. So here, for this particular application, a distributive law has been used. After the usage of that distributive law, we arrive at the equation AB plus AC bar plus BC. And for that equation, truth table has to be drawn. And how to write a truth table? We know that in the given expression, three variables are there, A, B and C, and only one output Y. If three variables are there, the number of possible combinations equation can have is always 2 to the power of 3. 2 to the power of n, we can say it in general. N refers to the number of input terminals. So here n is equal to 3. So 2 to the power of 3, we can have 8 different combinations starting from 0, 0, 0 to 1, 1, 1. For this, the truth table is written, and in digital circuits, all the logic diagrams, they have to be verified, they have to be demonstrated with the help of this truth table. So this is a logic diagram using basic gates. According to that equation, we know that the number of gates that we are going to require, they are basically here 3 gates we require. One is NOT gate 7404, then AND gate 7408, and then OR gate 7432. Okay, let's demonstrate the first experiment, that is the verification of Boolean expressions. For the expression, we require 3 basic gates. One is 2 input OR gate, then 2 input AND gate, and another one is 1 inverter. So these 3 gates are required. So we are going to make use the ICs for them. So here this is the digital IC trainer kit on which all the experiments are going to be demonstrated, and these are the sockets, IC sockets. On these IC sockets we are going to mount the ICs, and for this Boolean expression to work, we have to provide the inputs and also we have to get the outputs, isn't it? So these are the LEDs which are meant for logic input, and these are the logic output LEDs. If the LED goes on, it indicates logic 1, and if the LED goes off, it indicates logic 0. Let us mount the ICs on the IC socket. The first IC that I am going to mount is 7432. Then let us have other 3 ICs also, 7404, then 7408. While rigging up the circuit, always make sure that the IC trainer kit should be switched off. Now let us start for rigging up the circuit. For that we have to take the patch cords. These ICs, they belong to the family of TTL. If any IC is starting with the number 74, it belongs to TTL family. And this is a 14-pin dual inline package IC. In this socket is meant for 20 pins, but the ICs what we are going to use, they are having only 14 pins. So we have to count the pins as 1, 2, 3, 4, 5, 6, 7, then 8, 9, 10, 11, 12, 13, 14. In this pin, the 7th pin, 1, 2, 3, 4, 5, 6, 7. This pin is supposed to be connected to ground, and the 14th pin has to be connected to plus VCC, and it requires VCC of plus 5 volts. For all the ICs, we have to make the same connection. 7th pin is connected to ground and the 14th pin is connected to VCC. Then, by looking into the circuit diagram, we have to make the connections. Prior to that, we have to take the 3 input switches. The input variables that we are using for this expression, they are A, B and C. So, let us take this as A input, this as B input and this as C input. So, this is A, this is B and C. So, the leftmost significant input, this is A, the rightmost input is C, A, B, C. So, whenever we are using the gate, we always have to make sure that we always take the variable A from this patch cord, B from this patch cord and C from this patch cord, isn't it? The expression that we are going to rig up the circuit is AB plus AC bar plus BC. Let us start the rigging up the circuit. So this is the digital IC trainer kit that we are going to use for the demonstration of digital logic circuit experiments. And let's begin with the demonstration of the first experiment, that is the realization of simple Boolean expressions using logic gates. So here the circuit, according to the circuit diagram that was shown to you earlier, the circuit has been rigged up using the available patch cords, and we have used the ICs 7404 as a NOT gate, 7432 as a 2-input OR gate, and 7408 it's used for the realization of 2-input AND gate. And also the truth table for this circuit, it was shown. Let us observe the output. According to the truth table, let us observe the output and the input switches. For the combination 0, 0, 0, let us switch on the trainer kit. For the combination 0, 0, 0, the output should be 0. For the combination 0, 0, 1, the output should be 0. The next combination is 0, 1, 0, the output should be 0. For the next combination, the output should glow. Yes, it's coming. 0, 1, 1. Next, for the next combination, 1, 0, 0, the output is 1. 1, 0, 1, the output is 0. 1, 1, 0, the output is glowing, and for 1, 1, 1 also, the output is 1. The glowing of LED indicates the input value as 1. If the LEDs are down, it indicates the binary digit as 0.